All right, let's talk about one of the biggest problems in AI right now. All the most powerful models, they're basically locked away in these massive, super expensive data centers. But what if you could run a supercomputer-level AI right from your living room just using the gadgets you already have? Well, a brand new framework called Exo says you can, and today we're going to dive deep into how it works.
You know, this quote from the frugal data scientist really just hits the nail on the head. It perfectly captures the paradox we're living with in AI. On one hand, you've got these incredible, almost magical models. But on the other hand, they're completely out of reach for most of us, stuck behind this massive wall of super expensive, specialized hardware. It's this exact problem that's stopping regular developers, researchers, and honestly, you and me, from getting our hands on the real power of AI.
So what do we call this big problem? Well, it actually has a name, the AI memory wall. And let's be clear, this isn't some software bug you can just patch. Nope, it's a deep, fundamental hardware problem. You could even say it's the biggest single thing holding back the whole AI revolution.
Okay, so think about it. It feels like every single week there's a new, mind-blowing AI model announced, right? You look at something like Kimi K2. It's open source, it has 1 trillion parameters, and a context window so big it can basically read an entire library of books. The promise is just, wow. But then comes the reality check. To get that model to do anything, even just to say hello, you need a computer the size of a small building. It's just not practical.
And let's put a hard number on that. Just to get a model like Llama 3.145B up and running, you need 8,400 gigabytes of RAM. 840. I mean, your fancy high-end gaming PC or your new MacBook Pro, it probably has 16, maybe 32 gigs. If you're really lucky, 64. We're not even in the same ballpark here. It's a completely different universe of computing power.
Yeah, this is such a big deal that people in the industry have a name for it. The RAM crisis. And this memory wall, it's the reason why all the real AI power is stuck in the hands of just a handful of huge companies. You know, the ones who can afford to build these billion-dollar data centers. But what if we didn't have to play their game? What if we could just tear that wall down ourselves?
And that leads us to a really radical new idea. Maybe the answer isn't to build bigger and bigger computers. Maybe the answer is to completely rethink how we're doing this from the ground up.
So here's the question that could change absolutely everything. What if we could just link together all the devices we already own? Think about it. Your laptop, your phone, maybe an old computer in the closet, your tablet, all that power that's just sitting there doing nothing most of the time. What if we could pool it all together to create our own personal AI supercomputer?
The analogy here is actually pretty perfect. Just think of it like BitTorrent, but instead of sharing files, we're sharing AI models. It's a peer-to-peer system, which just means every device is an equal partner. There's no main server. They all just work together, weaving themselves into this mesh network that can run these massive models that no single one of them could ever hope to run alone.
And look, this isn't some far-off science fiction idea. It's a real, working, open-source project, and it's called the Exo framework. So let's pop the hood and see what makes this thing tick.
Okay, so the first piece of magic here is how simple it is to get started. Exo uses something called zero configuration networking. What does that mean for you? It means you just run the app on your different computers and that's it. They automatically find each other on your network. You don't have to mess with IP addresses or complicated settings. It really, truly just works.
So this chart really breaks down the nuts and bolts. That discovery part we just talked about, it uses a simple UDP broadcast. Again, the impact is zero manual setup for you. But the really crucial part is the network mesh. It's truly peer-to-peer. That means there's no boss computer telling everyone else what to do. Any device can kick off a task. And why does that matter? It means there's no single point of failure. If one computer goes offline, the whole thing doesn't crash. It's super resilient.
Okay, but finding each other is the easy part. The real challenge is getting all these different devices to talk to each other fast enough to actually work together. And this is where Exo pulls out its secret weapon. It's called RDMA, that's Remote Direct Memory Access, and it runs over the brand new Thunderbolt 5 standard. This is literally technology that was, until very recently, only found in multi-million-dollar data centers. Now, it's coming to computers you can actually buy.
And this chart right here shows you why that is such a game changer. Look at normal Ethernet. The latency, the delay, is hundreds of microseconds. Why? Because every piece of data has to take this slow, clunky trip through the computer's operating system. But RDMA? It's like a secret private highway. It completely bypasses the operating system, letting one computer's memory talk directly to another's. And the result? Look at that bottom row. the latency drops to under 5 microseconds. That is so ridiculously fast that it basically tricks a group of separate computers into thinking they're all one single giant machine.
Okay, so that's all the theory, which is cool. But what does all this incredible performance actually mean in the real world? What can you do with it? Well, let's take a look at the benchmarks.
Prepare to have your mind blown, because this is where it gets nuts. With a cluster of just 4 Mac Studios, machines you can just go out and buy, Exo can run that 1 trillion parameter Kimi K2 model at over 28 tokens per second. A token is basically a word, so that's like typing and getting a response in real time. It's completely interactive. And I have to say it again, this is performance that, up until right now, would have cost you millions of dollars in server hardware.
And this chart really shows why that RDMA tech is the key ingredient. Here we're comparing Exo to llama.cpp, which is kind of the gold standard for running models on your own machine. With one computer, they're pretty close. But look what happens when you add a second, a third, a fourth machine. The old way actually gets slower because the network just becomes a traffic jam. But Exo, because of that super fast direct communication, it just gets faster and faster. This is what real scaling looks like.
All right, so let's zoom out for a second and think about the big picture. What does it actually mean when anyone, and I mean anyone, can run a cutting-edge, state-of-the-art AI right from their home office? The implications here are, well, they're huge. What we're talking about here is a genuine paradigm shift. It's a fundamental change in how we think about AI. We're moving away from a future where AI is a centralized thing, like a power plant, controlled by just a few giant companies. And we're moving towards a future where AI is more like a personal computer, a decentralized, powerful tool that belongs to you.
And the benefits of that shift are massive. Let's start with the big one, privacy. If the AI is running on your own machines, your most sensitive data never has to leave your house and never gets sent to some third-party server. Then there's cost. You're not paying some huge monthly subscription fee. You're just using the hardware you already paid for. And when you put those two together, what you get is the democratization of AI. It levels the playing field so anyone, from a kid in their bedroom to a small research lab, can build and innovate with the best of them.
And really, that's the ultimate, most exciting question this whole idea leaves us with. This technology has the potential to transform AI from something that we just consume, something that's delivered to us, into something we can truly create with, privately, powerfully, on our own terms. So when the tools to build a future are finally in everyone's hands, the only question left is, what new worlds will we build?